All right. So, hello, my name is Michael Ogata. I'm a computer scientist in the cybersecurity and privacy applications group in the Applied Cybersecurity Division here at NIST. I'm also a principal lead alongside Alpair for the secure software development, security, and operations project here that we're all here to talk about today. This project is, as Alpair mentioned, a central guiding document behind how we design the DevSecOps project itself. So now I want to go into the background and the design philosophy of the SSDF itself. If you're familiar with the NIST Cybersecurity Framework, the SSDF takes a similar approach. Its goal is to provide a common language to describe sound, secure software development practices. That is what you're actually doing on the ground when you're developing software. It does this by helping an organization document its existing development practices while identifying gaps and future targets as part of a continuous improvement process. The framework seeks to provide a common language for use not only within an organization, but between different software producers and software acquirers. The SSDF isn't meant to reinvent the wheel, so it leverages existing software security documentation and practices from existing standards, existing guidance, and existing organizations' best practices. This has the add-on benefit of not putting additional stressors on organizations that have already adopted established practices. Indeed, this is one of the main reasons why the framework has been so readily embraced by the development community. So the three of the SSDF's strengths are its intended audience, its flexibility, and its customizability. Because it's intended to foster communication both horizontally and vertically, the guidance contained within the framework is applicable to both software producers, cost vendors, government software shops, etc., and software consumers. It's intended to provide a high-level view to the C-suite while pointing to technical resources needed to actualize its guidance. It's flexible because it considers organizations of any size or cybersecurity sophistication. Also, its main thrust is to be as automatable as possible, which lends to easier integration into existing workflows. Finally, because the SSDF doesn't mandate specific technologies, platforms, programming languages, or development life cycles, it can be profiled by any sector or community. And that's one thing I alluded to before, what that AI profile is, and I'll talk about that at the end. So the SSDF is a collection of fundamental, sound, and secure recommended practices for the production of secure software. These practices are organized into 4 groups, each group focusing on a desirable strategic target to be met by the software development process for the organization. To support each of the practices, the SSDF identifies tasks, that is, one or more actions that may need to be performed to help fulfill a practice. And to further flesh out each task, it provides examples of the types of tools, processes, or other methods that can be used to help implement the tasks, along with references to extant sources for secure documentation and development. So the SSDF is divided into 4 strategic practice groups. There's prepare the organization, which is to ensure that its people, processes, and technology are prepared to perform secure software development. There's protect the software from tampering and unauthorized access. There's produced well secure software that has minimal security vulnerabilities in its releases, and respond to vulnerabilities so that when vulnerabilities are discovered, the organization can appropriately respond and also adapt to prevent similar vulnerabilities from occurring in the future. I'll spend the next few slides describing some of the practices for each of the groups, but I won't go into super detail because the document's online for everybody to share. The preparing the organization group includes practices like defining overall security requirements, that is, defining both infrastructure requirements as well as requirements for the organizational developed software. So you can see sort of the merging between building zero trust environments and building secure software and where those things meet. Identifying and enforcing roles and responsibilities within the organization, including providing for role-based training for organizations, for individuals within those roles. It's for implementing supporting tool chains and automation to reduce human effort and to improve accuracy, reproducibility, usability, and comprehensiveness. And that is really having the organization embrace those types of tool chains and evangelizing them, championing them. It also helps to define and use criteria for software security checks to help ensure that the software resulting from the SDLC meets the organization's expectations by defining and using criteria for checking the software security during development. And finally, it mandates implementing and maintaining secure environments for software development. And as I mentioned before, that's where it sort of overlaps with the Zero Trust project that we worked on prior to this. The Protect the Software group provides for integrity provenance of the software that is being produced. This includes protecting source code and other artifacts such as executable code or infrastructure as code from unauthorized access and tampering through mechanisms like access control, version control, and code signing. The SSDF also recommends providing integrity and provenance information to software consumers to help organizations further down the supply chain verify and validate the software that they use. Furthermore, it enables organizations to identify potential vulnerabilities within their infrastructures. And finally, the SSDF recommends that organizations preserve software releases between different versions to help identify, analyze, and eliminate vulnerabilities discovered in after release. So if customers are not running all the same versions, you've got a pedigree of archived releases so that you can go back and identify who's running what. So the Produce Well-Secured Software Practices Group is the lion's share of the guidance inside NIST 800-218. And it really is all of the software practices that you probably think of and that most immediately come to mind when you think about secure software development. It includes requirements for designing software to meet the security requirements that were set forth in the organization stages. It mandates or recommends using things like using risk and threat modeling to evaluate the security risk of software, using standardized security features for logging and identity management, et cetera. It also includes things like how long and defining when you have periodic code reviews, how often you're revisiting your requirements, and the like. I also I know that PW3 is grayed out on that slide. I include that just because that was in the original version, moved between version 1.0 and 1.1 into a different control group. So we just want to make sure that nobody gets confused when they skip from 2 to 4. But yeah, so the rest of the controls emphasize things like reusing secure components that have already been vetted inside your organization, whether or not they were developed in-house or they were obtained from external organizations like open source projects or software that you've licensed. And PW 6 and 9 provide guidance on configuration, both on configuring your build environments and compilers and interpreters to be secure, and also building software that has secure by default settings so that when customers install that software, they're not less vulnerable by having something misconfigured. The final SSDF practice group is Respond to Vulnerabilities, and it describes the reactive practices that are part of a strong secure software development process. You want to be able to be nimble and respond and confirm to ongoing vulnerabilities and make sure that they're identified quickly so that you can remediate them. This includes being plugged into different vulnerability or CWE sources, making sure that you can compare those to things inside your infrastructure to know that you've been compromised or if your product has been compromised. It includes requirements for assessing, prioritizing, and remediating vulnerabilities, that is, being able to successfully order them in terms of severity so that you can target your limited resources. And it also includes recommendations for being able to analyze vulnerabilities to assess their root causes and to help reduce the frequency of vulnerabilities in the future. So the Secure Software Development Practices for Generative AI and Dual-Use Foundation Models is a companion document to the SSDF. It was also included as part of sort of a core driving force as we were developing the project. It was mandated as part of an executive order, and it takes on the NIST identifier NIST 800-218A. So what is a community profile? While the SSDF proper is designed to be domain agnostic, A community profile focuses this guidance on a particular resource area or class of produced software. In 218A, it seeks to address organizations that develop or utilize AI models. As such, it reinterprets its practices and tasks through the lens of AI development. Activities like data sourcing, training, and evaluation are considered as they surround the impact of AI models on other pieces of the software. That said, the profile itself supplements all the recommendations contained within the core SSDF. All practices and tasks remain unchanged from the SSDF unless they're explicitly tagged as such. It's important to note that, as with the SSDF version 1.0, operations are closely, the operations part of software development is considered largely out of scope, and is also, so the operation of an AI model was considered out of scope for this document as well. Therefore, AI model deployment and operations are considered sort of a separate document for enforcement. Yeah, that must have gotten pulled. That's fine. So this community profile does augment the SSDF core guidance by providing additional characteristics for each task. Each task is assigned a priority that reflects its relative importance to the other tasks in the profile. The profile also includes recommendations, considerations, and general notes for each task where appropriate. And finally, the 218A calls attention to AI-specific informative references. These additions to the SSDF were constructed through work with our leading AI organizations via public comment, workshops, and general feedback. So I'm going to go through this next one really quick because we're running out of time for this session. So how does this all fit together into the SSDF? As I stated in into the DevSecOps project. As I stated in my opening, the SSDF acted as a central guiding document behind how we designed the DevSecOps project. This project's foundational technical task requires the construction of software development processes that implement DevSecOps practices. That is, build software factories that resemble what is actually done in the real world. To be useful, this necessitates the selection, configuration, and integration of many different IT technologies that satisfy some minimal viable set of characteristics to emulate an actual software shop. And as we began to decompose the project's notional model into phases and activities and components, we began to explore which of these features had the potential to fulfill goals specific to specific tasks in the SSDF. And so this will be reflected in the output of our project in our practice guides when it's released, and it will be updated with lessons learned as we do each of our builds. So our goals are to map each of the tasks in 218 and 218A to each of the components and activities that we identified as part of our notional reference model.